Hello everyone and welcome to lesson 4.6 on quadratic inequalities. So this is the last lesson in unit 4. We've learned a ton of stuff about quadratics, all the algebra and how to manipulate the three different forms, how to solve quadratics, applications and word problems with quadratics, and finally we end with inequalities. And these are pretty simple. When we say inequality, remember we've seen this word before. Unequal, meaning not equal, right? So if something's not equal to something, then it's probably more than it or less than it, right? So we're just looking at less than, greater than relations with quadratic functions. Now, the steps for solving these pretty simple. You solve them the same way you solve equations, right? So in 4.4, we talked about, hey, always set it equal to 0, and then factor or use quadratic formula, right? And that finds your roots. Well, you got to do the same thing with this too, but it's not equal to 0. It'll be less than 0 or it'll be greater than 0, right? But in either case, you're setting it in relation to 0, okay? From there, you're just going to find the roots and then think about what intervals around those roots satisfy your inequality. So kind of like a quick example before I actually do a real example. If you think about, let's say like I have a parabola and it crosses through these two roots. And let's say it's upside down, so it kind of looks like this, right? If, I don't know, let's call this like 3 and let's call this like 7, right? Then if you wanted to know, this is the curve f, if you wanted to know when f was more than 0, well or let's say greater than or equal to 0, right? Then that would mean that the y values are more than 0. And you see this is a y-axis, and so, where's my little highlighter? Here we go. All this upper region, if it's up here, that's what's meant by y is more than 0, or in other words, f of x is greater than or equal to 0. So the piece of the curve that's above 0 is between 3 and 7, right? So it's between 3 and 7. And so the way you could write this is on the x-axis, it's the x values such that they are less than or equal to 7, but also less than or equal to, or greater than or equal to 3. And as an interval, you could write this as bracket 3 to 7 bracket, because it's inclusive, yeah? If you were to, vice versa, say f of x, let's say strictly less than 0, so this would be the literal opposite interval, then less than 0, let's erase this, boop, boop. Less than 0 is going to be everything down here, right? But if I'm less than 0, well, then I'm not in between 3 and 7. I'm on the outskirts of it, right? So I'm everything down here, which is everything from 3 and on. 3 and on. And then everything from 7 and on, kind of like this. So the way you would say that is x is less than 3 or it's greater than 7, right? And as an interval, you could write that as negative infinity to 3 unioned with 7 to infinity. Yeah? Because that's what I've done in blue there. Okay? And that's what we need. These are what our solutions look like. We're looking at when the quadratic is above the x-axis or below the x-axis, right? But to see, the reason the roots are important is because the roots on your quadratic are kind of an indicator of whether you're going to change from negative to positive, right? Or from positive to negative. So that's why you're interested in finding the roots, because that's where you're going to change sign if you pass through those roots. Okay, so example 1. Here we go, example 1. You say, give the solution set satisfying x squared plus 3x minus 28 is greater than or equal to 0. Cool. Well, it's already set in relation to 0, so we're good to go. Your objective is to find the roots, and then we're going to kind of think about what the parabola looks like around those roots. So first thing, we've talked about 3 ways you can find roots. You can factor, you can complete the square to solve, or you can use the quadratic formula, okay? This one looks factorable and pretty easily with negative 28 and 3. It looks like 7 minus 4 satisfies this. And, you know, if you want to do grouping, we could do grouping, but you don't have to. You can kind of skip and say it's x plus 7, x minus 4, right? But again, you know, just to model grouping one more time, because why not? You can say x squared plus 7x minus 4 minus 28. Sorry, 4x minus 28. And then you could say, okay, GCF is x plus 7 minus 4 times x plus 7. And this, of course, gets me x minus 4 and x plus 7, right? So, you know, you could shortcut it, or you can do the grouping method to verify the factoring right there. I want to know where the roots are. And, of course, as a reminder, the roots are what make this equal to 0. So you say, by zero product property, if x minus 4 equals 0, then 0 times a number is 0. If x plus 7 is 0, then a number times 0 is 0. And so this will help us find our roots, right? Therefore, the solutions, or the roots to this, I should say, the roots are 4 and negative 7. And I want you to be careful with this idea of, you just flip the signs. Careful there. You don't just flip the signs willy-nilly. The reason it's 4 is because it's 4 minus 4 gets you 0, okay? You're looking for what number for x makes the factor equal to 0. You don't just flip the number just 'cause, okay? Now that you have your roots, let's put a little number line here. And I'm going to put, here's negative 7 as a root, and here's 4 as a root. And this is just my x-axis, really. So these are like x-intercepts. And your parabola, you know, if you think about it, if you have two roots like this, the parabola could only do one of two things. It could either come down and then go back up, or it could go up and then go back down. I mean, it's got to be one or the other, right? It's not going to, it's not going to do anything like that because it is just a parabola. It's just a quadratic. So it's got to be one or the other. Now, two ways I'm going to show you think about this. I think one is superior to the other, but hey, who knows, right? You might do whichever one you like. The first way is to plug in a number in the intervals to test and see whether they come out to be positive or negative. So for example, you know, a number between negative 7 and 4 is 0. And of course, if I go back to the main polynomial I started with right here, if I do 0 squared plus 3 times 0, I mean, that's nothing. And I end up with negative 28. Well, negative 28 is negative, right? And so what this means is the curve, the parabola, has to be beneath the x-axis. Oh my goodness, bless me. Has to be beneath the x-axis between these two values, right? Which means it could only be doing this, yeah? The parabola simply must look like this because it has to be below. The hump has to be in below and between negative 7 and 4 like this, okay? Which naturally means that this side is positive and this side is positive because it's now above, right? They cross through the roots and change sign. And so now I just look at my inequality, right? A little highlight this for you again, right there. And what you're looking at here is the greater than sign. You're saying it's greater than or equal to 0, and to be more than 0 means to be positive. So what that means is we're interested in the region where this parabola is positive. And you'll notice based off this picture, where it's positive is this region to the right of 4 and this region to the left of negative 7. Okay? So I could say as my final answer, I could say x is more than or equal to 4, or it's less than or equal to negative 7. This is one way to write it. Another way to write it is negative infinity up to negative 7 inclusive unioned with 4 to infinity. Okay? And that is an alternative way. And that's it. Yeah? We've done it. Now, I mentioned two ways of determining the way this parabola looks. The first method was to just plug in a number. Here's the second method. And the second method is, if you remember function transformations, right? If you have x squared versus negative x squared, right? Well, x squared is just an upward facing parabola. Negative x squared is undergoing a vertical transformation reflected upside down. So that makes it go facing this way. And so if that exponent term, x squared, if that's negative, then it's going to be facing down. Nothing else really affects that. Because if you have negative x squared plus 7x plus 1, hey, that's facing down because the lead coefficient is negative, okay? We learned that about function transformations with that a value, right? So seeing that the lead coefficient was 1 means it was positive, and positive means it's pointed upwards, means, oh, yeah, it was going to do this. So I'll leave that to you. If you like to test a point and see the sign, you could do that. Or if you just want to think about transformations, is it already, it's normal U shape, or is it vertically reflected? And you would just see if the leading coefficient's negative. Okay. Here's an example, another one that might kind of show you that lead coefficient business. So it says, give the solution set satisfying negative 6x squared plus 5x plus 21 is less greater than or equal to 0. And we can solve it like so, right? Now, I don't know how I want to teach you guys this, because the standard teacher thing to do is to say, oh, is the lead negative? Then you should divide by a negative. But sometimes students say, why? And I would just say, I don't know, it's just kind of good practice. Factoring's easiest when the lead coefficient is positive, but it's not essential. So here's my challenge to you. I'm going to do it the traditional teacher way and say, hey, divide by a negative sign. Okay, divide by a negative. This way, the factoring will be a little bit easier with a positive coefficient. But you could try factoring this regardless of whether it's negative or not. Okay, that is my challenge to you if you'd like to attempt to do so. Okay, so let's find the solution set to this. Thank goodness it's already set in relation to 0. So as I was just saying, I'm going to divide by a negative, and this will get me 6x squared minus 5x minus 21. And if you divide by a negative, or if you multiply by a negative, you flip the inequality sign, like so. And that's very, very important because you're literally reflecting it over the number line. Okay, so to factor this, we do 6 times 21. I get negative 126 and negative 5. And this one's a little tough to factor because it's not totally straightforward, clear, because we don't really know what or recognize 126. But I do believe it comes out to be negative 14 and 9. Okay? If you think 14 times 10 is 140, no. Is it? Wait, actually, hold on. Is it this? 14. Here, I'm getting out. You can't see this, but I'm getting out my little calculator. 14 times 9. Huh, it is. Plus 14. Yeah, okay, I'm right. Yeah, 14 times 10 is 140, so subtract 14, you're at 126. Okay, cool. Sorry for wasting your time with that. This means I can factor it with this. Factor by grouping. Don't you love to see it? GCF, the first two terms, you should get, not 3x, 2x, and then 3x minus 7, plus GCF of 3, and then 3x minus 7 again. Perfect. Yeah, look at that. 3x minus 7 and 2x plus 3. So that's equals 0. So I'm just trying to find the roots, right? Finding the roots, number line, and then see what the parabola looks like. What are my roots? Well, the roots are what make it 0. So remember how earlier I said don't just flip the signs, right? Like what the heck signs are you flipping? Are you going to say 7 and negative 3? It's a no. Look, what does x need to be to make those factors 0? Set them equal to 0, and then solve for x. So I'm going to get 7/3, and then I'm also going to get, looks like, -3/2. Okay? So let's go ahead and do that. Make my little number line. Hello. And I say, here's -3/2, and here's 7/3. And I just need to see, what does this parabola look like? Now, a few ways you can do this. Again, you could plug in 0, and then you could look at the original expression and then say, that's nothing, that's positive. And so since this is going to be positive, means it's going to come up like this and then down through. So that's one way. So negative, positive, negative. Parabolas will always sort of fluctuate like this unless they bounce off. And then also, again, you could have known that it was downward facing because the lead coefficient was negative, okay? Now again, we're going to divert our attention to the fact that when I'm looking at this inequality, the sign is more than 0, which means positive. So positive is this region in between those two numbers. And it looks like these are included because it's equal to, right? Greater than or equal to. So I could say x is less than or equal to 7/3 or greater than or equal to -3/2. Okay? You could also say bracket -3/2 to 7/3 and bracket. Okay. So that's sort of two examples modeled, also with the upside down image there to kind of see that. Okay. All right. Let's go ahead and do example 3. And honestly, for the purposes of the video, I think I'm going to skip example 4. I'm so sorry. But the reason this is because they're really just hitting the same skills. And in class, we're just doing these problems kind of over and over till we kind of see how they're done. I like these two examples because even though they're both factoring, this factoring is a little bit more complicated, and you also have the negative that you have to deal with. But what's notable about example 3 and 4, and the reason they're different from the previous two, is neither are factorable. So if you look at this expression, -1 and -2, well, there's not two numbers that multiply to get -1 and add to get -2. You can't factor that. Looks like it's the same situation here. If you do -44 and -2, I don't think, 44, you could do 4 and 11, you could do 2 and 22. That's kind of it, isn't it, right? 44 and 1, you're not going to get -2. So what do you do if it's not factorable? Well, you have to find the roots a different way. And we can also find roots using the quadratic formula. You say x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Don't you just love it? Oh my God. So what is this, right? This is a quadratic formula. It helps you find the roots set equal to 0, right? And what we're referring to is ABC from standard form, ax squared plus bx plus c. And so from this I can draw that, say, okay, a is 1, right? B is the coefficient -2, and c is -1. So I'm just going to take these numbers and plug them into the quadratic formula. So -b is -2. Give it a little double negative if you like. And this is -2 quantity squared minus 4 times a is 1 times c is -1 all over 2 times a is 1. Now let's clean that up. It's a little ugly. Double -2 makes +2. 2 times 1 on bottom is just 2. This is square root of -2 squared is 4. And then 4 times 1 times -1 is -4. So it's minus -4. Okay? Of course, 4 minus -4, that's just like 4 plus 4, which is 8. I've got this. And then you can simplify square root of 8. Square root of 8, well, that's square root of 4 times 2. So that's square root of 4 times square root of 2. And square root of 4 is 2. So square root of 8 is 2 root 2, meaning you could say 2 plus or minus 2 root 2 over 2. Ah, that's too many 2's. Oh, that's my little joke right there. Don't know if you appreciate that. So I designed this intentionally, just so I designed this problem so that I could say there's too many 2's, just so you know. This was intentional. So anyway, I'm going to simplify this a little bit more. If you like, you could split up the fraction like this, right? If you like to sort of do that visual for yourself, 2 over 2 is 1, and then those 2's cancel, you're left with root 2. So notice my roots are 1 plus root 2 and 1 minus root 2, okay? So if I draw a number line, I have 1 plus root 2. Oh, no, sorry. The minus should come first, obviously. You say, and then plus 1 plus root 2, right? So what's this parabola look like? Is it facing up or down? And if I look at the lead coefficient, it's positive 1. So positive 1 means it's going to be a U shape facing upwards like this. Of course, you could also test a number. For example, the number 1 is in between these two numbers. And so you could say 1 squared minus 2 times 1 minus 1. Isn't that 1 minus 3? So it's negative, right? So it's negative. And that makes sense because down here is negative, okay? Of course, the sign I wanted was when this is less than 0. So that means when it's negative, and it's negative down here. So I want in between these two values. So my answer here would be x is less than 1 plus root 2, but greater than 1 minus root 2. Or parenthesis 1 minus root 2, comma 1 plus root 2. This is my interval, but they're not inclusive because it's not greater than, or it's not equal to, okay? And that's that. So yeah, if you can't find the roots by factoring, you could use quadratic formula and do the same thing. I'm not going to do example 4. I think it would be redundant. It is the same idea that you're kind of seeing here over and over, okay?